Hilchos Kiddush Hachodesh Perek Shiva Asar. The laws of sanctification of the new month, chapter 17. This is, no doubt, the most complicated chapter in these halachot, but it's not so much complicated because of the content. In other words, if you're good at absorbing technical information and following instructions, then this chapter of Rambam is no different than any other chapter of Rambam. But what makes it complex is to understand why the Rambam is saying what he's saying, the background behind each adjustment or each correction he's going to make today. So technically, like if we didn't care so much to understand, we could just learn today's Rambam and get through it, no problem. But because we want to understand a little bit about the mechanism behind what's triggering the Rambam to make these adjustments, that's what makes it complicated. And whereas other chapters, we had like one adjustment per chapter to understand, for some reason the Rambam in this chapter stuck in like 7 different corrections into one chapter. So it's very loaded. And so because it's loaded, that's what makes it complex. But we're going to try our best to get through it. I have some wonderful illustrations, which I haven't publicly said yet, but this is not my own illustrations. These pictures that I've been showing the last few days, they come from a man whose name is Rabbi Mendel Darren. He made an actual program. He developed a computer program to match the Rambam's Kiddush Hachodesh. And yeah.
So if I can go to...
You can go on YouTube, type in Mendel Darren Kiddush Hachodesh. You can see his videos.
D-E-R-N-E-N?
D-E-R-E-N.
E-N.
And he has a whole program that he made where you can follow the Rambam's computations, you can make your own, you can adjust it to your current time, and it's 3D on the computer. I think the future of Kiddush HaChodesh is in VR. Like they're going to make one day a program where you can put on the goggles and actually see, properly visualize every detail the Rambam says. But for us, we're going to try our best in 2D to understand what's going on. So let's just remind ourselves where we're at. And today, I'm not going to do the reminding. The Rambam will do the reminding. Says the Rambam, Halacha Aleph, Kol hadvarim shehikdamnu. Everything which I have given as a preface until this point is all for one purpose. Kedei sheyiyu asidim umuchanim liyidiyah sariyah. It's all for you to have the information so you'll be ready and prepared to know whether you're going to sight the new moon. After 29 and a half days, the moon and the sun have met again. They're in alignment. The moon then continues after the molad to move a little bit further east, away from the sun. And that night, the following night, by sunset, after the sun dips below the horizon, the moon, which is further east, has a small window of time to perhaps be able to be seen if it got far enough from the sun. By the way, just realize that. Because in the beginning of the month, the moon is so close to the sun, the window of time for the witnesses to see the new moon was tiny. Like we think, they had all night to see it. It's just that time between sunset and moonset that any witnesses could have saw any moon. And on the night of Rosh Chodesh, it's about 5 minutes.
You mean sunset and moon rise?
And moon set, because the moon is further east, so it's also setting below the horizon on the west, very, very, very quickly later. But there's a little bit of time between sunset and moonset. That's the time that you're able to see the moon. It's a very, very small window. So you have to know whether you're going to be able to sight the new moon during that time. Looking out, looking out at the universe from a bird's eye view, we talk about it as a side-to-side thing, an east-to-west thing. But really for us, east to west is up and down. That's why everything we're going to see on this screen is going to go from side to side, but it's really about visualizing it for us from top to bottom. And that's the point. The point of it all is to know whether we're going to be able to see the new moon on the night following the molad. So, once you have all the information, let's get to it. When you actually wish to know whether or not the moon will be sighted, taschil v'tachshav, so you must begin by calculating all the things that we gave you before. V'toitzi, first take out, achieve the results of mekayim hashemesh ha'amiti u'mekayim hayareach ha'amiti. What is the true position of the sun? What is the true position of the moon? U'mekayim harosh lishas hariyah, as well as the placement of the rosh, that's the point of departure. Remember, the moon's orbit is inclined 5 degrees further off of the sun's orbit. It only meets at 2 points. The beginning point is called the rosh, the head. Figure out where that is. Subtract the position, the true position of the sun from the true position of the moon. In English we call that figure out the distance between them. Because if the sun is at 10 degrees and the moon is at 20 degrees, by subtracting 10 from 20, you have a total of 10. That's the distance between the sun and the moon. The remainder is what's called the first longitude. Remember, Oirech in the Rambam is a term for the east-west distance between two stars, longitude. Knowing as you do the placement of the Rosh, the point of departure for the moon's orbit from the sun's orbit, and the placement of the moon, who figure out where the moon is, and if it's northerly inclined to the ecliptic and to the sun's orbit, or if it's southerly inclined. That's called the first latitude. The reason why the Rambam calls them first is because they're going to be adjusted throughout this chapter. We're going to have a second longitude and a third, etc. This initial distance of longitude and latitude, all right. This initial distance of longitude and latitude, you should be very careful with. In other words, always remember it and have both of these pieces of information ready. Now the Rambam is going to tell us something in the next two halachot, which is super important before we even begin. He says, you know what, before you even start dealing with whether the moon is going to be sighted, let me give you some keys that are going to determine whether or not you even have to get into the headache. And in order to understand these keys, let's take a look at this next slide over here. The moon and the sun are journeying around the earth at a diagonal inclination. Yes? They're more or less following the Galgal HaMazalot. Because the whole Galgal HaMazalot is inclined relative to the equator, that means that at any point, the moon is either heading north or heading south. Right? In other words, it's going from east to west longitudinally. But if you think about it in terms of the inclination, it's either heading north or heading south. From the bottom of the Galgal HaMazalot, which is about 270 degrees, all the way to the top, it always has a northerly orientation. While it's heading eastward away from the sun, while it's journeying eastward, it's also journeying northward, upward. But in another part of the year, the moon has a southerly orientation. In other words, it's still traveling eastward relative to the equator, relative to the earth, but in terms of its journey against the Galgal HaMazalot, because the top is inclined the most north, so when it's heading downwards, it's also heading south. Why does this make a difference? Because remember that everything that's being calculated in this chapter is from the horizon of Jerusalem, where the more north something is, the later it will set. The more south something is, the earlier it will set. So take a look at what happens during the different times of the year. This is while the moon has a northerly orientation, during the half of the year that it's climbing northward. This is the moon just after sunset. The sun has already set below the horizon, that's the yellow line. It's already below the horizon of Jerusalem. The moon, during that time, is climbing away from the sun, eastward, but it's also going northward. And you can see the more north you go, the longer journey you have to the horizon. The horizon runs this way, so the more north you go, the further the moon will have till it gets to the horizon. And therefore, in that part of the year, when the moon has a northerly orientation, right after sunset, it's constantly getting further from the earth and further from the horizon. Further from the sun and further from the horizon, such that its time to moonset is getting longer. On the other hand, when it's climbing downwards, this is the moon when it has a southerly orientation, it is getting further away from the sun, still going further east, but because it's going south, the line between it and the horizon is shorter, not as long as it was when it was going north. You saw the difference? This is the moon going north. As it gets further away from the sun, the line is increasing by a lot. Now that it's going south, the line is increasing, but not by so much, by shorter. So therefore,
all the way almost to. Is this accurate?
No, this is
100 you're giving?
no, this is exaggerated, but just to bring out the point.
Okay.
That when it's going north, it's getting further from the sun, but also further from the horizon. When it's going south, it's getting further from the sun, but not so far from the horizon. Why does this make a difference? Because besides for figuring out how far the moon is from the sun, we have to know whether the moon has a northerly orientation and a southerly orientation. If it has a northerly orientation, there's more time. We can give ourselves more time to be able to see the moon. If it has a southerly orientation, we have to give ourselves less time to see the moon. So therefore the Rambam says the following keys in Halacha Gimel and Dalet. V'hisboinein ba'oirech hazeh harishain. Check out the initial longitude. Check out the initial distance between the sun and the moon. Im yatsa lecha teisha miles b'shave oipachos. If, and the Rambam is talking now about northerly orientation, as he's going to say in Halacha Daled. We're talking when it's northerly inclined. If the longitude is 9 degrees or less, there's 9 degrees of distance between sun and the moon or less, Teda bevadai she'i efshel lo'ilam she'yirah hayareach ba'isei halayla b'chol eretz Yisrael. You can know with certainty there's no moon going to be sighted tonight. It's just too close. Ve'enat hatzarich cheshbon acher. You don't need any further calculations. Close the book now. Go home. You're not going to have the moon. But if the longitude is more than 15 degrees, it's so far from the sun that there'll for sure be enough time to see the new moon in the land of Israel. No need for any calculations. Again, close the book and go home. It's only if the first longitude is from 9 degrees to 15 degrees, that's when you're going to have to get involved and start inquiring and analyzing the calculations, whether it's going to be possible to sight the moon or not.
Over here it says Tisha.
Yeah. Halacha Daled. Bamed dvarim amurim. When is the window between 9 and 15 degrees? Kishahaya mikayim hayareach ha'amiti mitchilas mazal gedi ad soif mazal ta'im. When the true position of the moon is anywhere between the beginning of Capricorn, the goat, until the Gemini, which is the southerly orientation, again, when it's climbing upward. The northerly orientation, when it's climbing upwards.
It's like almost half the circle.
Yeah, it is half the circle. Half the circle when it's climbing northwards. Avolim haya mikayim hayareach mitchilas mazal sartan ad soif mazal keshes. But if it's the opposite, if it's a southerly orientation, the moon is heading downwards. So now the window is different. If the initial longitude is 10 degrees or less, you can know that the moon will certainly not be sighted that night in Israel. And only if the initial longitude is 24 degrees or more, that's when it'll certainly be seen in the whole land of Israel. But between 10 and 24, you're going to have to analyze and get into the calculations. Why in the south is the window so much bigger, of the window of headache? In other words, between 10 and 24 you have to analyze. That's because of what I showed you over here. In the northerly orientation, it's getting further from the sun and further from the horizon. So once you hit a small window of 15 degrees, you're going to for sure see the moon. But in the south, because when it gets further from the sun, it still stays close to the horizon, as you can see in the picture here, it gets further, but the line between the horizon is still shorter. You need a much bigger window to know with certainty that the moon will be sighted. And therefore, so long as you're within the window of 10 to 24 degrees, you're going to have to get involved in the cheshbonot, in the calculations of whether we're going to be able to sight the moon or not. So let's assume we are in the window. We are in that window of 10 to 24 degrees or 9 to 15 degrees. Now that Rambam will continue to guide us step by step how to arrive at the conclusion of whether you're going to be able to sight the new moon. Just quickly, what's going to happen in this chapter? You can see a bunch of adjustments. We began with the Oirech Rishon and the Reichav Rishon. Again, the initial longitude, the initial east-west distance between the sun and the moon, and the initial latitude, the initial north-south position of the moon. During this chapter, the Rambam is going to come to the Orech Sheni, the second longitude, by subtracting. You can see there's a minus sign. From the Orech Rishon, there's always a subtraction. The Orech Sheni is always shorter than the Orech Rishon. But to the Orech Shlishi, sometimes you subtract, sometimes you add, you get to the third longitude. Then sometimes you subtract, sometimes you add, and you get to the fourth longitude. And then sometimes you add or subtract, and you get to the final arc of sighting. That's the end. For the latitude, only one adjustment is made. So we get to longitude 1.0, 2.0, 3.0, 4.0, and after you hit 4.0, then you have the arc of sighting. For the latitude, it's 1.0 and 2.0, and that's it. Okay, so that's where we're heading. And the Rambam begins with the Oirech Rishon, the first longitude, shortening it to the second longitude. Why are we shortening it? So again, I'm going to explain this on the outside first, and then we'll go into the Rambam. Throughout these chapters, we've learned that there's a Makom ha'emtsoi and a Makom ha'amiti, an average position of a planet and the true position of the planet. The average position is on the orbit relative to itself. The true position is from the perspective of the observer on Earth. But the truth is that all the true positions, the ones that were made from the perspective of Earth, were drawn from the center, the belly of Earth. But nobody stands in the belly of Earth. We stand on the surface of Earth. The distance between the belly of Earth and the surface of Earth, as we know from science today, is about 4,000 miles. 4,000 miles of difference can make a huge difference in terms of how you see something out in the heavens. So here you see the white line and the blue line. The white line represents, as I wrote, the view from the center of Earth. So the moon, the true position, because we're looking at it from Earth, but if you're looking at it from the center of the Earth, you'll come to the white line. It'll be, let's say, at 175 degrees. But then if you stepped onto the surface of Earth and you got 4,000 miles away in Jerusalem where it matters, now you're going to see it against the blue line. And it's going to come back to 170. It's a big difference. And again, the main difference is relative to the sun. Because if the sun is from here, the moon, by adjusting that, we get a shorter distance between the two. The view from the surface of Earth will always be, as I wrote over here, it's always more westward. Let's leave the math out of it, okay? But when you're on the surface of Earth, you're always going to see the moon more west, further back on the ecliptic. So it's going to shorten the distance between the sun and the moon. How much you shorten the distance by depends on which constellation you're in, because each constellation is viewed from a different angle from Jerusalem. That's what the Rambam tells us right now. Halacha hey, let's begin. What are the calculations that are involved in determining whether you're going to be able to sight the moon? First thing you have to do is check it out, figure out which constellation is the moon in. Where on the ecliptic, where on the mazalot is it? And you always subtract something right now. Says the Rambam, in the constellation of Aries, you subtract from the initial longitude 59 minutes. In the mazel of Taurus, you bring it back 1 degree. In the constellation of Gemini, you bring it back 58 minutes, just under a degree. In the constellation of Cancer, bring it back 52 minutes. In the mazel of Leo, bring it back 43 minutes. In the mazel of Virgo, you bring it back 37 minutes. In the Libra, you bring it back 34 minutes. In the Akrav, in Scorpio, also 34 minutes. In the Keshes, in the mazel of Sagittarius, the archer, bring it back 36 minutes. Capricorn, bring it back 44. In the Aquarius, you bring it back 53 minutes. And if it's in Pisces, you bring it back 58 degrees. What remains of the longitude after you've subtracted these minutes and this degree, that's called the second longitude. We've adjusted the distance between the sun and the moon by subtracting. Says the Rambam halacha vav, why do we remove these minutes? What's the reason for this adjustment? The true position of the moon is not the place that it's actually going to be seen, as the commentaries explain, because you're on the surface of Earth, not in the center. There's a difference between them in longitude and latitude. This is called the difference of sighting. We're in the first part of Shinoi Mara ha'oirech, the difference of sighting for the longitude. The Rambam will immediately give us the difference in sighting for the latitude as well. The difference of sighting in terms of the longitude. At the time of sighting, in other words, in the beginning of the month, is always subtracted from the initial longitude, as we've explained. Because from the surface of Earth, at the beginning of the month, you will always observe the moon more west than it initially would be from the perspective of the center of the Earth. Now, in Halacha Zayin, we're going to learn about the Shinoi Mara Haroichav, the difference in sighting latitudinally. In other words, till now we talked about in terms of the east-west distance between the sun and the moon. Viewing it from Earth will cause it to be more west. Now let's talk about the north-south inclination. Remember that the moon at any given time is inclined either to the north or to the south of the Galgal HaMazalot. But remember this. This is Earth, okay? You're viewing Earth from the outside view. The Galgal HaMazalot, that's represented by the blue little tags, they form a circle around the Earth, inclined at 23.5 degrees from the equator. The moon's Galgal, that's the red line, is inclined further, 5 degrees maximum, for a total of 28.5 degrees. But where is Jerusalem relative to the equator? Yerushalayim relative to the equator, as we saw in the earlier chapters, in chapter 11, the Rambam said it's about 32 degrees off of the equator. So if you think about it, somebody in Jerusalem looking out to the heavens is technically always looking down at the moon. The moon is always more south, even in the moon's own most northerly inclination. How far north can the moon get? 28.5 degrees off the equator. In Jerusalem, you're always on top of that. You're always 32 degrees above the equator. So you're always going to see the moon more south. So even if you know, for example, that the moon's inclination tonight is northerly, but you have to take away a little bit of that. You have to move it down a little southerly to adjust for your viewpoint. And same thing if it's in the south. If the moon is inclined south, you have to make it even more south, because you're going to see it from the top down at a point that's even more south than the original inclination. That's called the Shinui Mare Haroichav. That's what the Rambam says over here in Halacha Zayin. Avol Shinui Mare Haroichav, but the difference in sighting as it relates to the latitude, Im Hayareichav Hayareach Tzfaini, if the inclination of the moon on this night, you calculate it, and it's northerly, Goyrin Chalakim Shel Shinui Mare Haroichav Min Haroichav Harishain. You will have to subtract a certain amount of minutes caused by this difference in sighting from the original latitude. But if the inclination of the moon was southerly, you will add to whatever the current latitude is. You will add a little bit based on this difference in sighting. And whatever the latitude is, after you add or subtract those minutes, that's called latitude 2.0. And again, the principle being that in Jerusalem, you're always looking down at the moon. You will always see the moon more south than what it actually is. So if it's in the north, you have to make it more south by diminishing the inclination. If it's more south, if it's in the south, you have to make it even more south by increasing the inclination. Says the Rambam, halacha ches, so how much are the minutes that need to be subtracted or added to the latitude? If the moon is in the mazel of Aries, 9 minutes will again either be added or subtracted. If it's in the north, you subtract it. If it's in the south, you add it. 10 minutes for Taurus. 16 minutes for Gemini. 27 minutes for Cancer. 38 minutes for Leo. 44 minutes for Virgo. 46 minutes for Libra. 45 minutes for Scorpio. 44 minutes for Sagittarius. 36 minutes for Capricorn. 27 minutes for Aquarius. And if it's in Pisces, it's 12 minutes. And again, it's always either added or subtracted. Added for the south, subtracted for the north.
Table would be nice.
Yeah, table would be nice. I wasn't able to make one before, I'm sorry. Oh, yeah. Just to see it, just to visualize it. Once you know these minutes, either subtract them from the latitude 1.0 or add them, as I've told you. And you will get latitude 2.0. You already know if it's northerly or southerly. It's just going to be either less northerly or more southerly. Figure out how many degrees and how many minutes is this latitude 2.0. Have it ready, because it's going to be used in a moment. By the way, the commentaries point out that there's one case where you can actually convert a northerly reichav to a southerly one. Because if the northerly inclination of the moon is very small, and it requires you to subtract a certain amount of minutes that will cross that threshold, you might end up having an inclination which is northerly but will be observed southerly. But it's very rare. usually if it's in the north, it's just going to get less north, but it'll stay in the north. And if it's in the south, it'll get more south and stay in the south. Okay.
Dip below the equator, right?
Exactly. Dip below its inclination. Its Reish.
I see, okay.
Okay? Yud. Next adjustment. Now we're back to the longitude, okay? So we have longitude 2.0 and latitude 2.0. The longitude 2.0 is always shorter. Latitude 2.0 either got less northerly or more southerly. The Achar Kach Tachzer says the Rambam, then go back, V'tikach min hareichav hasheni hazeh miktsasai, and take off a part of this latitude 2.0, mipnei shehayareach nolois ma'at b'ma'agoloi, because the moon turns a little bit in its orbit. That's all the explanation we're going to get from the Rambam. Because the moon turns a little bit in the orbit. What does that mean? Let me try to illustrate what this means. This white line is the moon as it's observed from the center of Earth. This blue line is the moon as it's observed from the surface of the Earth. In other words, we're looking at that slide that I showed you before, inverted.
Yeah.
Now we're looking outwards, onto Earth. When you know that the moon is going to be observed at this point from the surface of Earth, it's actually not going to be observed literally in the Galgal HaMazalot, because it's inclined to the north. It's viewed a little bit above the Galgal HaMazalot. We just use the degree as though we were drawing a line downwards from the point of the moon's inclination down to the belt of the Mazalot. However, while this is nice for mathematical purposes, it's not good for practical purposes. Because remember that the Earth, the north is on top, the south is on bottom. Because the Mazalot are inclined, we have to correct that position relative to the Galgal Hayomi, to the daily turn of reality from east to west. In other words, in order to know where the moon will actually be sighted, I can't draw a line diagonally down to the Galgal HaMazalot. I have to draw a line, maybe here you can see it visually. Yeah, this is the view from outside. The Galgal HaMazalot is the Galgal Hayomi is turning everything all around. So you have to really know where is the moon relative to these lines of longitude. And for that reason, you have to actually draw the line going this way. So even if the mathematical results tell you that the moon is here, and you would like to draw the line this way, so that it fits with the inclined Galgal HaMazalot, for practical purposes, you're going to have to draw the line down this way, so that it relates to the lines of longitude, which will tell you if it's practically going to be able to be seen. That's a great way of saying it. You take the inclined Galgal HaMazalot, if you were to flatten it,
you could see it would move.
it would move to the left.
Yeah.
This line would move to the left.
Correct.
Wait, which line will move to the left?
This line.
With the white
The white line.
Right.
The blue line.
The white line would move to where the blue line is now.
It would straighten itself out by moving.
Yes.
It's not straight.
Yes. So again, this is the initial position of the moon. It's this far from the sun. By adjusting it to the view from Earth, we've brought it to this point. But it's not enough to draw the line as it reflects itself in the Galgal HaMazalot. You must draw the line straight down relative to the lines of longitude. And so in this case, when the moon is northerly inclined, the longitude is now getting shorter. Watch what happens on the other side. What if the moon would be southerly inclined? If the moon is southerly inclined, so again, this is the initial line that we would want to draw to align it with the Galgal HaMazalot. But in truth, we have to align it to the lines of longitude, and so it comes out to be further from the sun. This line of correction is going to bring the moon further from the sun. Again, in the case of the northerly inclination, drawing the line will bring it closer to the sun. In the case of the southerly inclination, drawing that line, the blue line will bring it further from the sun.
Well, why do you have to do that again? Why do you have to straighten it out to the longitude?
Because for purposes of simple mathematical calculation, in the end of the day, we want to know where the moon's going to be at sunset.
I see. Yeah.
Right? Sunset is determined by the Galgal Hayomi, which turns everything from east to west.
Okay.
So you have to know where the moon is going to be relative to that. So I can know where will the moon actually be sighted in my horizon. We're not done yet. There's still more steps. But that's the basic purpose of this adjustment. Because if all you did was adjust the line to the Galgal HaMazalot, but by sunset, when reality pushes the moon down to the horizon, you're going to be expecting the moon to be up here, but really in the viewpoint of the Galgal HaYomi, it's going to be down here. So you must account for that adjustment. Or in the case of the southerly inclination, it's going to be further up.
The opposite.
Yes. So therefore, you have to make this adjustment. Now, by the way, this is only true if the moon in general is on its journey northward. Remember in the beginning of the Shir the northerly inclined and the southerly inclined? If the moon is on its journey northward, then a northerly inclination is shorter and southerly is longer. If it's the opposite, then it's the opposite. If the moon is heading downwards, then a northerly inclination is going to cause the line to get longer, and a southerly inclination is going to cause it to get shorter. That's what the Rambam is about to tell us right now. And because it's based on the inclination of the moon, north and south, so the table that Rambam is about to give us is built on fractions of the latitude. It's built on fractions of the Reichav because it's the Reichav that dictates to us how to make this adjustment. Depending on if the moon is north or south, that's how we're going to know where to draw this blue line. See, if it's north, we're drawing it this way. If it's south, we're drawing it that way. So the inclination of the moon to the north or to the south dictates this next adjustment. That's what the Rambam says again, halacha yud. You must take a fraction of this second latitude. Because the moon is turning a bit in its circle. Turning a bit in its circle means it's being influenced by the Galgal HaYomi that's pushing it from due east to due west. And for that reason, it's going to be seen as though it has turned a bit away from its original position. How much is this little bit that you have to take away? So the Rambam gives us the table. If it's from the beginning of Aries to 20 degrees in, or the opposite side of the Galgal, from the beginning of Libra to 20 degrees in, take 2/5 of the Reicha. This is the trigonometry which is involved in achieving this exact adjustment. We're not getting into why the Rambam gives us these numbers, just trust him. Okay, so it's 2/5 for this case.
So that means you subtract or add.
Well, he's going to tell you soon what to do with it.
Okay.
Just get the number. If it's from 20 degrees of Aries and 10 degrees of Taurus, or the opposite side of the circle, 20 of Libra till 10 in Scorpio, take an entire third of this latitude. From 10 in Taurus till 20, or from 10 in Scorpio till 20, take a quarter of the latitude. From 20 in Taurus till the end, or 20 in Scorpio till the end, the 30 degrees, take 1/5 of the latitude. The first 10 degrees of Gemini or Sagittarius, take 1/6 of the latitude. The next 10 degrees of Gemini or Sagittarius, take 1/12, half of a sixth. Take a from the second to last sixth, 20 degrees to 25 degrees of Gemini or Sagittarius. You take a quarter of a sixth, that's 1/24th. It's a tiny, tiny adjustment. From 5 from 25 of Gemini to 5 of Cancer, from 25 of Sagittarius to 5 of Capricorn. Over here, there's no adjustment to be made, because no matter where the moon is inclined relative, that line will meet the same line relative to the longitudinal lines. Now we're heading backwards, from 5 degrees in Cancer till 10, from 5 degrees in Capricorn till 10. You grab a 16th of the latitude. From 10 in Cancer to 20, 10 in Capricorn to 20, you take a half of a sixth, a 12th.
The previous paragraph says you're 1/24.
Where?
Reviash to say.
Yeah, that's, what did I say?
1/16.
I'm sorry. Revia Shtusai. Yeah, 24th, I'm sorry. Yeah. V'miya mekayim ha'yarech me'eser mimazal sartan ad soifai. Ay me'eser mimazal gedi ad soifai, tikam ha'yarech ha'vasheni shtusai. From 20 of Cancer to the end, 20 of Capricorn till the end, you take a sixth of the latitude. V'miya ha'yarech mitchilas mazal ari ad eser malas mimenu. Ay mitchilas mazal dli ad eser malas mimenu, tikach mimenu ha'yarech ha'vasheni chamishisa, you take a fifth of the latitude. From 10 to 20 of Leo or Aquarius. You take a quarter of the latitude. From 20 of Leo till 10 of Virgo. 20 of Aquarius till 10 of Pisces. You take a full third of the latitude. From 10 degrees of Virgo till the end, 10 degrees of Pisces till the end, you take 2/5 of the second latitude. This amount that you've taken from the latitude, is called the circuit, the turn of the moon. And what do you do with it? Do you subtract, do you add? That depends where you are in the year and whether the inclination is north or south. Check out the inclination of the moon, the latitudinal inclination of the moon. And see if it's north or south. As I showed you over here, if it's to the north, tigra you must subtract this adjustment. Because again, to reach the line of longitude that it's parallel to is going to shorten the distance. But if the inclination was to the south, you will then add that number over here. The blue line is going to be further away from the sun, so you will add that adjustment to the second longitude. When do we go this way? When the moon is on its journey northward, from Capricorn to Gemini. But if the moon is on a journey southward, the opposite is true. A northerly inclination of the moon will cause a longer longitude. You will add the circuit to the second longitude. But if it's a southerly inclination, then you will subtract that circuit from the second longitude, because again, on the other side, everything flips. To match the position of the moon to the Galgal, Hayomi goes the opposite way. In the north, it gets longer. In the south, it gets shorter. What the second longitude is, after you've done this addition or subtraction, is called the third longitude. Vida. And no, of course, if there is no turning of the circuit, as the Rambam said in one of the lines over there, that between 25 and 5 of Gemini and Cancer, there is no nilizat, circuit, like turning of the circuit, little turning. And the calculations, the table of adjustment said, don't remove anything from the latitude. Then of course, the second longitude 2.0, is 3.0 with no difference of more or less.
No Lisa Smago means that the moon is exactly with the longitude?
Yes. Yes. Drawing a line wouldn't help. In other words, the moon is so little inclined that line, it's already parallel to the lines of longitude. But wait, there's more. Yud Beis. Now, check out this longitude 3.0. The amount of degrees between the moon and the sun. You got to see where it is on the ecliptic. Which constellation is it? And what's going to happen now is, let me just say it outside. What we just did helped us orient the moon to the lines of longitude. Like you were saying before, it just helped us flatten the circle and move it to the way that we're accustomed to. But we still haven't positioned the moon relative to Jerusalem's actual horizon. Remember, in Jerusalem, let's see that picture again. We had this yesterday. When you're standing in Jerusalem and your horizon is like this is the amount of the heavens that you can see. The more north something is, the longer it'll take to set on your horizon. The more south something is, the shorter it'll take to set on your horizon. So, let's visualize. This is the last slide, just now with that blue dome showing you Jerusalem's horizon. You need to figure out, once you've oriented the moon's position to the lines of longitude, you have to draw a line parallel to the regular equator all the way to the horizon. This will tell you how long you have till the moon actually sets on the horizon. So this line here, although it is diagonal, it represents the previous adjustment. It represents that movement that we've made, and we moved the moon, a degree further or a degree closer. Let's just call that this degree, the white line, okay? Once we have that degree, we have to draw another parallel line that runs right to the horizon, so we can see how much time we actually have from the moon being there till it sets. Because again, if we just keep this line in mind and say, oh, that's the position of the moon, we're still calculating it on a diagonal line. We're still calculating it on the distance of the moon to the sun. By drawing this line, we actually orient it to the horizon of Jerusalem. This is going to be called longitude 4.0. And the length of this line will depend on which constellation the moon is in. Because the more north it is, the longer the line will be. The more south it is, the shorter the line will be. So the Rambam says, again, let's read it again. Check out this longitude 3.0. The degrees between the moon and the sun. Which constellation is it? If it's about Pisces or Aries, add a sixth to the third longitude, because it's beginning to go north. If it's in Taurus or in Aquarius, add a fifth. If it's in Capricorn or Gemini, add a sixth. If it's in Sagittarius or Cancer, no need to add or subtract. It's going to be about the same amount to draw that line to the horizon. If the longitude is in Scorpio or Leo, subtract. It's going to be even shorter. A fifth. If it's in Libra or Virgo, you'd subtract a third. And what remains of that line after you add or after you subtract or leave it as is called longitude 4.0. And now, essentially, as the commentaries explain, we've determined not just the distance between the moon and the horizon, but also the time. How long we actually have after sunset. Because we know that the Galgal Hayomi rotates around the entire Earth 360 degrees every 24 hours, which comes out to 1 degree every 4 minutes. So the length of this line will actually give us the time that we have. From after sunset, how much time will it take for the moon to reach the horizon? However many degrees it is, that's every degree is 4 minutes. So that also, besides giving us distance, gives us the time. Now, because factually, the moon will either be more north or more south to the horizon, all of these adjustments were adjusting the east-west distance between the moon and the sun. But in the end of the day, because the moon has a roichav, has a latitudinal difference, it's going to be either north or south. So even if I make all these adjustments and I tell you if it's north setting later, south setting earlier, the fact that the moon is actually in the north or the south is going to make it even earlier or even later. And that's the final adjustment. Then return to the initial latitude. The commentaries here wonder why the initial, we already adjusted it, should be the Rechav Sheni. Most of the, even trigonometrically, the adjustment works better if you use the second latitude. But the point is, you return to the latitude. You always take 2/3. This is called the angle to adjust for the height of the country. In other words, from the observer on Jerusalem, he's always going to see the moon factually either north or south. Some say this Manas Geva Medina is the name for both corrections, this one and the last one, because they're both accounting for the fact that we're trying to bring the moon in line with the horizon.
Erech V and this one?
Yeah, are both called Manas Geva Medina. But certainly the last one is called Manas Geva Medina. And so now, check out and see. If the moon is inclined north, add this a little amount to the longitude. You can see it maybe over here. Yeah, you see? This is the line that we're going to draw out from the Roichav. And then that final adjustment is the final length. Because when it's north, you're going to see it later. If it's a southerly inclination, you subtract that amount from the current fourth longitude. Was after the longitude 4.0 has been adjusted, that's called the arc of sighting, because now you've done everything to orient yourself to where and when you're going to see the moon on your horizon, before it sets on your horizon. So the original longitude kind of was going like this, diagonal between the moon and the sun. We shortened it for the view of surface on Earth. Then we flattened it to orient it with the equator. Then we shortened it or lengthened it relative to our horizon. And then we accounted for the north-south difference by either lengthening or shortening that, and we end up with the final arc of sighting.
What's the north-south difference?
North difference means, in the end of the day, the moon is always to the north or to the south of the sun. Right?
Or to the south of the sun.
Whatever, yeah. In other words, because of Reichav HaYarech, it's always going to be north or south. Till now, we've been using that Reichav to influence the Oirech. We're saying there's a latitudinal difference. That's going to make the longitude different. But then you have to talk about the latitude relative to itself. There is a latitude. The moon is going to be either to the north or to the south. And the more north it is, the more time you have. So even if the northerliness of it influenced the longitude to be longer, the fact that it actually is north will make it even longer. Now that we have all the adjustments, the Rambam's going to help us visualize it for his time. Yud Gimel, Ketzad. How does this all look? Let's apply it all. The starting point is the 3rd of Nisan. We want to know, are we going to see the moon a month later, the night of Friday, second day of the month of Iyar, or not? You begin with the basics. Where's the sun? Where's the moon? How far north or south is the moon? As we've told you, the moon, the sun's true position is 7 degrees into Taurus and 9 minutes. Let's call that 37 degrees into the ecliptic, which begins at Aries. The moon is at 18 degrees of Taurus, or 48 degrees into the ecliptic, and 36 minutes. That's a difference of what? 7 to 18 is 11 degrees. And the current inclination of the moon is southerly at almost 4 degrees, 3 degrees 53 minutes. That is the initial latitude. If you subtract the distance between the sun and the moon, you're left with 11 degrees, 27 minutes. That's the initial longitude. The Rambam arranged it all so you can go with all the headaches, like all the way to the end. Since it's 11 degrees, right, it's within that window of 9 to 15 or 10 to 24, where you have to go through all the adjustments. So the first thing we do is we account for the difference in sighting from the surface of Earth. Since the moon is in Taurus, it's 1 degree of difference. And you have to subtract it, as we always do, from the first longitude. Now the distance between the moon and the sun is at 10 degrees, 27 minutes. For the southerly, for the latitudinal difference in sighting, the difference is asara chalakim. It's 10 minutes, and it's 10 minutes more. Since the latitudinal inclination was southerly, we have to add, make it more southerly, because again, from Jerusalem's point of view, everything always looks more south. 10 minutes. Now, the inclination of the moon to the south is at 4 degrees and 3 minutes. Then we do the next adjustment to orient the moon to the equator. Since the moon was at 18 degrees of Taurus, so we're in the frame where we take a quarter of the latitude, which is the circuit of the moon. Since the latitude of the moon was 4 degrees and 3 minutes. So a quarter of that is 1 degree and 1 minute. We're not going to be so exact. Let's just call it 1 degree and 1 minute. Because this orientation is taking place in a southerly inclination, and the moon is on a northerly orientation, it's heading north, you have to add this little amount to the second longitude, make it longer. We brought it back now to 11 degrees, 28 minutes. Remember, this is the Rambam is illustrating this point over here. When the Reichav HaYarech is in the south, and the moon is climbing northward, by drawing this blue line, the Eirech has gotten longer. And now, we're moving to the fourth longitude, adjusting it to the horizon, this one over here. Because the current longitude is in the mazel of Taurus, we have to add a little bit to the third longitude, a fifth, 2 degrees and 18 minutes. And now the fourth longitude is 13 degrees 46 minutes. And now, to account for the final arc of sighting, we've gone back to the first latitude, taken 2/3 of it, and we have now the angle for the height of the country, or in other words, which is again backing it up, drawing the line parallel to the Reichav. Because of the moon's inclination, there's a factual difference in where the moon is going to be sighted. So we have to take 2/3. But this time, 2 degrees, 35 minutes. But because it's southerly, unlike in this picture where it gets longer, it's actually going to get shorter. You're going to be left by subtracting this angle from the fourth longitude. We're back to 11 degrees and 11 minutes. That's the final arc of sighting on this night. Notice that after all this confusion back and forth, the Rambam began with the Eirech Rishon, the first longitude, was also 11 degrees, 27 minutes. Now by going back and forth, what do we end up with? 11 degrees and 11 minutes. Pretty much stays in the same area. Sometimes not. Differences could be more extreme. But in the Rambam's case, it was it stayed pretty stable. The thing that you can do with the arc of sighting to know how many degrees and how many minutes it is at every night of sighting at the beginning of any month that you would like to do.
Your phone went to 20% battery.
Okay, leave it. Tell me when it's at 10%. Okay, now that you have the final arc of sighting, the last step in this calculation is to compare this final arc with the original initial longitude. Tesvav, the achasha teitze keshazu. Once you achieve this final arc of sighting, tavinba, take a look at it. Vida, and you can know the following. She'im tia keshasariya teisha mailes epaches, I efshar she'yirah b'chol eretz Yisrael. Some texts here have us, but it's I efshar she'yirah b'chol eretz Yisrael. If it's 9 degrees or less, it's impossible to see the new moon. If the final arc of sighting is more than 14 degrees, it's impossible that it won't be seen. Everyone's going to see it in Israel. But between 10 and 14 degrees, and the Rambam, of course, arranged for his one to come out to that, 11 degrees, right? Compare the final arc of sighting with the initial longitude, and you will figure out whether the moon will be sightable or not based on the limits. These are the final kets, the final limits that will determine whether you can sight the new moon. They're referred to as the sighting limits. And if you just do the math here, you'll see, if together the numbers of the initial longitude and the Keshes Hara'iyah equal 22 or more, the moon is going to be seen. 22 or less, the moon is not going to be seen. You see how it works now. The Rambam says, Yud Zayin. The Elohim Kitzei Hara'iyah. What are the sighting limits? Im tiye keshasari iya miyeser al tesha milas at seif eser milas, so yeser al eser. V'ya'ira charishin shleshasri milas so yeser. If the final arc of sighting is about just over 9 to just over 10 degrees, and the initial longitude is 13 or more, so you see there, it's more than 22, vada yeira will certainly be seen. But if the arc is less than 9, or the longitude is less than 9, it's not going to be seen. Yudches. If the final arc of sighting will be from just above 10 to just above 11 degrees, and the initial longitude 12 degrees or more, vada yeira will certainly be seen. But if the final arc is less, or the initial longitude is less, it won't be seen. Yutes. If the final arc of sighting is from above 11 till just above 12, and the initial longitude is 11 degrees, it will certainly be seen. This is the Rambam's case right here. The final arc of sighting was above 11, and the initial longitude was above 11. So it'll be seen. But if the arc or the longitude will be less, it will not be seen. If the final arc of sighting will be 12 degrees or more, 13 degrees or more, and the initial longitude is 10 degrees or more, vada yeira will certainly be seen. Again, there's a combined amount of more than 22. But if the arc or the longitude is less, it will not be seen. If the final arc is more than 13 or more till more than 14, and the initial longitude is 9 degrees or more, vada yeira, the moon will certainly be seen. But again, for less than that, it will not be seen. These are the end of the limits because the window is only between 9 and 14 degrees. Ketzad, how will this be applied? Let's return to our final arc of sighting, which we came to in the calculations of the second day of the month of Iyar. We've achieved the result of 11 degrees and 11 minutes, as you already know. Since it's between 10 and 14, we have to compare it. We compare it to the initial longitude. You already know that the initial longitude was 11 degrees and 27 minutes. Since they were both more than 11, can do a round of applause. We're going to figure out that the moon will be sighted on this night according to the limits that have been imposed by the sages. And so too you can compare and contrast every final arc of sighting with its initial longitude, and you will know whether or not the moon will be seen. And the Rambam concludes with a thought. Chav Gimel. You've seen from all these last actions how many calculations are involved with the moon. How many additions, how many subtractions. And that's after I've worked very hard till I came up with easy paths which aren't so complicated to compute. Because the moon has major incongruities, major crookednesses in its orbit. Therefore, the sages say, the sun, we know it's setting. The moon, we don't. It's so complicated. It's making circles and squiggles, and we have to make other circles to account for it, and adjustments, and all kinds of things. The sages say, sometimes the moon comes down with a long longitude, sometimes with a short one. As you've seen from these calculations. You got to add, you got to subtract sometimes, till you figure out the final arc of sighting. And sometimes the arc of sighting is big, the arc of sighting is small. These are all parts of the astronomy that's involved in sighting the moon. The reason for all the calculations, why we add this number, why we subtract, and how we figured out all these things and all the proofs for all these things, That's not part of these halachot. Hi chachmas hatkufos v'hagimatriyos. That is the wisdom of astronomy and geometry. Shechibru b'chachmei yavan sfarim harbe, which the Greek sages have made many books on this. These are the ones that also Jewish sages have gotten a hold of. But the books that were compiled, that were authored by Jewish sages, the ones that existed in the times of the prophets and days of the children of Yisachar, they never reached us. We don't have the Jewish books. We only have the Greek sources. But it doesn't matter. Who cares that it came from a Greek book? If everything in the Greek book is known with clear proofs that have no falsehood, and no man can think and contemplate, have doubts about them, so we don't care about the author. A very big principle that Rambam is teaching us. Whether it's a prophet that made it or a Gentile that made it. Because if the reason of the matter was revealed and the truth is proven with proofs that have no falsehood, we don't care. We're not relying on the person who taught it, who said it. We're relying on the proof that has been revealed, the reason that has become known. And if the logic makes sense, if the theory cashes out, then we can use it. And therefore, in my book, says the Rambam, I've used these Greek sources to determine the calculations. I've only given you the actual calculation, not giving you the reason, but you can already see how complicated it is, and the Rambam made it easy for us. Just we got only the basics of it, okay? And that was, this was the easy version. You can imagine what the hard version looks like. But that's the end of chapter 17.